Hello. In this video, I'm going to show you how to solve analysis of cantilever beam using ANSYS APDL. We have been given a problem statement, and the analysis of the problem statement is that the beam is a cantilever beam where it is subjected to a point load at C, D, and B located at distance 1 meter, 2 meter, and 3.5 meter from the fixed end. And the Young's modulus is 200 GPa and the Poisson's ratio is 0.3. The cross-sectional area of the wing is 0.12 meter and 0.2 meter. That is width into height. Now let's go to ANSYS APDL. For this problem, we will be solving by using element type beam and 2D 2-node beam 188 element. First, as it is, go to File, Clear and Start New. Do not read file. Okay. Go to Preferences. We have solving structural analysis, so go to Give Structural. Click on OK. Go to Preferences, Element Type, Add. To add beam, select beam 2-node 188. Click on OK and go to Options. Change element behavior, that is K3 to cubic form. Click on OK. Close it. Next, we have to give the properties of material of the beam. So go to Material Props, Material Model, Structural, Linear, Elastic, Isotropic. Give the Young's modulus that has been given in the problem. In the problem, we have been given Young's modulus of 200 GPa, that is 200 E3, and Poisson's ratio of 0.3. Click on OK and exit from the material model. Next, we have to create the cross-section area of the beam. Cross-section of the beam. So go to Section, select Beam, Common Section. Here, give the breadth as 0.12 and height as 0.2. Click on OK. Next step is to create nodes. Go to Modeling, Create Nodes in Active Coordinate System. Give the node number as 1 and node number 1 will be at origin. Give origin, click on Apply. Node number 2. Node number 2 is at a distance of 1 meter from the origin. So give it as 1. Click on Apply. Give node number 3 and node number 3 is at a distance of 2 meter from the origin. Give it as 2. Click on Apply. Node number 4 is at a distance of 3.5 meter from the origin. Click on OK. Now you will get the nodes. Now to join the nodes, go to Element, Attributes, check this material number and the section number. It should be 1. Click on OK. Go to Auto Numbered through nodes. From 1 to 2, click on OK. Select 2 to 3, apply. 3 to 4, click on OK. Now the nodes has been joined. Next, we have to constrain the structure. To constrain, go to Loads, Define Loads, Apply Structural, Displacement on Nodes. Select node number 1 because it is a cantilever beam and it should be fixed at one end, and node number 1 should be fixed. Click on OK. All DFs will be constrained and value of the displacement is 0. Click on OK. Now to apply force or moment at node 2, 3 and 4, go to force and moment below the displacement itself. Give on nodes, select node number 2, click on OK, give the value, change the value of the direction of force to f of y and give the force as minus 20,000. We have been taking minus because it is a transverse load that is acting perpendicular to the beam. Click on OK, apply. Next, select node number 3, click on OK, and again a minus 20,000 kilonewton force is acting downwards. So take minus 20,000, click on apply. Select node number 4, click on OK. Now a 10,010 kilonewton force is acting at node number 4. So give minus 10,000, click on OK. Now the loads has been applied to the nodes. Next step is go to solve, solution, solve, current LS. Click on OK and the solution is done. Next step is to take the readings or the result. Go to general processor, uh, list result, reaction solution. Click on all items, click on OK. This is the reaction force command prompt, and you can note down the reaction force in the structure. Next, go to nodal solution, DOF solution, displacement vector sum. OK. You will get the displacement acting in the structure. Next, in the command prompt, type set and click enter. Next, we have to define table. So go to element table, define table, add. Here we have to the label for the item. Let us label SBTI. Let's use capital SBTI and drop down, select by sequence SMISC and give the reference number as 32. Click on apply. Next, give it as SBTJ, a drop down, select by sequence number and give it as the reference number as 37. The reference number 32 and 37 gives us the bending stress on the element positive y side of the beam. Click on apply. Now SBBI, drop down, select by sequence number and give it as 33 reference number. Click on apply. SBBJ, drop down section by sequence number SMIC 38. Click on apply. The reference number 33 and 38 will give us the bending stress on the element negative y side of a beam. Next, to get shear force and bending moment diagram, we have to give the label as SF5 and at the bottom drop down section select by sequence number and give the reference number as 6. Click on apply, and for SFJ, that is J node, go to drop down by sequence number and give it as 19. Click on apply. The reference number 6 and 19 will give you the uh, shear force diagram for the structure, and for bending moment diagram label it as BMI by sequence number and give it as 3. Click on apply. BMJ down by sequence number 16. Click on OK. The reference number 3 and 16 will give you the bending moment in the Z direction. This you can get the bending moment diagram. Press close. Next step is go to plot result, deformed shape, deformed plus undeformed. Click on OK. You will get the maximum deformation of the structure. Next is go to contour plot, line element table, element table item at node I should be SBTI and this should be SBTJ. Click on OK. You will get the bending stress on the element positive Y side of the beam. And if you select SBBI and SBBJ, click on OK. You will get the bending stress of the element negative Y side of the beam. And to get the shear force and bending moment diagram, go to line element table, select SFI. For reference, you can check here it is node I, it should be I itself, and it is node J, so you have to select SFJ. Click on OK. You will get the shear force diagram and maximum and minimum shear force at the structures. Maximum shear force is acting at this region and minimum is acting at this region. Next, go to line element result. To get the bending moment, select BMI and BMJ. Click on OK. You will get the bending moment diagram. And here you will get the minimum and maximum value of deformation or bending moment. Sorry, not deformation, it is bending moment. That's all. You can note down this one and get the solution or get ready the table. Thank you.